Hello everyone, my name is Marek Ko-w. I will be talking today about things about microservices you wish you never knew. So motivation for my talk was I was trying to answer the question everyone talking about microservices are not the golden hammer, and no one really says what they are good about, what problem do they solve, and what are they bad. During my preparation, instead of answering that question, it turned out that every architecture you build, you can do well or you can screw up completely. So I will focus today based on my experience, on my team experience, what are the traps you can fall into during microservice implementation, how to spot them right on time, and how to avoid them. Okay, little bit of context, of background. So I'm simply, with one word, I'm developer. I'm holding software architect's role, but luckily in hybris in my company where I work. Software architect is developer, is developing. We don't do diagrams, we don't, this kind of really boring architect stuff. I have 14 years experience from different projects, but currently I'm working in my most interesting project. We trying to build customer profile based on a graph database. So customer profile is just all information coming from the action of the user, like click streams. We trying to analyze this and create graph depicting this user. This graph then is used for analytics and, for instance, some personalized recommendation or advertisement are displayed to you. So that's really interesting. I'm agile enthusiast, and I think the microservices and Scrum don't go well with manager. Maybe I will give you an example later on. So from that perspective, I will be explaining the microservices. Agenda, another introduction slide. So agenda will be really simple. We started from monolith. This is our main product. It's called Hybris Commerce Suite. And we migrated or rewritten it for the microservice architecture. And I will not be talking about how we rewritten, which way we took, what mistakes we made, just the comparison between two architectures based on our experience. So what I call monolith, our hybris commerce suite is not fully monolithic. It's really hard to classify architectural system as fully, modular, monolithic, microservice. You have flavors of each of them. And hybris platform is modular. You have modules and you can plug in, plug out. It's really work like that, but it has monolithic characteristics. And I will tell later on the next slide what those are, what we want to solve. But let's focus now what we like in our current architecture, maybe not current, our base product. So we liked easy monitoring. That's really something really cool. We can scale, but each of the cluster nodes is the same. We are using Dynatrace for that, and aggregation of all the metrics are trivial, and one person can have holistic view of the whole system, and yeah, can do anything with that. Debugging, another thing we really like. This is connected with running whole system on one machine in seconds. It's really like that. You can start whole system, big system, in seconds and debug it, stop, reproduce some problems, optimize it, so profile it. And this is what we like the most in our product. Maybe let's take back, you probably don't know Hybris. Hybris is e-commerce company, so what we produce is the base for the e-commerce solutions. We build really big e-commerce solutions like H&M, or some really big customers are using our platform to build their e-commerce solutions. Okay, so what we want to solve? Those are characteristics of our monolithic system. which we want to solve, and we decided to go into microservice architecture. So first one is extensibility. That's really difficult in our architecture. Every new feature, every new bug, everything we want to do is really painful and time-consuming. We have something like butterfly effect, too much coupling, so we add one module or change one module, and we have bug in completely unrelated part of the system. So this is what we want to solve. Next one, I think this is the most important, or one of the most important factors, is release cycle. We have release cycle like 3 months. After 3 months, regular developer don't remember what was before. We need fast feedback from the clients. We don't want to maintain the old version, propagate something, do merging. We don't want to do that. Now, another thing is scalability. We can scale, of course. We can have cluster, but this cluster maintains state. So there is a limit. We can have dozens of node instances, but not hundreds or thousands. We would like to have that. Another thing with scalability is the resource management. So we wasting resources. We can scale all or nothing. So we have to provision the big server, install the software on that server, and probably only one of the modules needs to be scaled. That's not currently possible. Replaceability, the last one. So everything in monolithic application needs to be perfect from the first time. So we have a lot of code, a lot of classes which are there for 5 years or more, and no one is there enough or have enough time to replace that. And we want to change that. So the answer would be microservices. You probably know what are microservices, but let's explain from my perspective what I call microservice. So the best definition I found, even it's really short, is smart endpoints, dumb pipes. And it really tells what the microservice is. So each of the service should be smart. This is micro. And all the logic is in there. And no logic in the connections, and the microservice should be self-aware, ecosystem-aware, so it works. There is a network latency, the other services can break, can be unavailable. This all logic, and also, of course, business logic as well, needs to be in microservice. Let's compare that microservice with other architecture. I chose an SOA and monolith and 4 factors to compare. So with SOA is quite difficult because SOA, someone says that, and I agree with that, that if you do SOA right, you get microservices. But in SOA, from my definition, we mean integrating bigger system, bigger, maybe even monolithic system, and having ESB as a connection integration layer. So this is SOA. I'm talking about monolith, of course, the single application which is monolithic, does everything, and is only one. Okay, so independent release cycles. In the microservices, we need to aim for the independent release cycle. So the smaller service, the easier to release is independently. Of course, we need to care about all the coupling. That's not granted, but microservice architecture encourages you to have this separation, to have this decoupling. In SOA, you might release your services independently, but usually if you upgrade version of one service, you need to upgrade also ESB, so update some adapters or something like that. So it's not independent anymore. Monolith. Of course, you can release all or nothing. That's the monolithic characteristics. Small, fits in your head, so it's about replaceability. The smaller, the easier to replace. But to be small, it needs to fit in your head, and one person or one team needs to understand microservice fully. This is not the case in monolith. If you have bigger system, at some point you get you do not, you lost your track of all features. You ask one person and he doesn't know, or she doesn't know what's going on in the system as a whole. In SOA, yeah, again, it doesn't define the size of the service, but the services in SOA tends to be really big. Next one, single responsibility. Again, microservice should be single responsibility. And in monolith, of course, this is not the case. It does everything. In SOA, again, it's not defined, but usually the big services are not single responsible. Resiliency, this is the most interesting. In monolithic architecture, and I was taking part in some project, this architecture encourages developer to don't care about the outside world. So everything is taken for granted. There is no network latency and so on. In SOA, we have ESB, and the developer of the service, or even there is a tendency to integrate ready services, so the service doesn't care about the outside world as well. All the resiliency is developed in the ESB. That's the difference, I think, between microservice and SOA. Yeah, okay, we know what are the microservices, from my opinion, and we can check how they solve problems we wanted to solve after we decided to do something else from our monolithic architecture. So how we solve extensibility? We just add another microservice to our ecosystem, to our system, and it's that simple as that. Release cycle. The smaller, the easier to release, right? I think that's obvious. And yeah, we have to be careful, of course, of this coupling, this kind of thing. It's not granted by architecture. We have to keep the discipline to achieve that. Scalability, that's interesting. Of course, you can start many instances of one service, and that should solve the problem. But that's not all. This is also not granted by microservice architecture. We need to take into account, for instance, 12 factor. 12 factors, you probably heard about 12 factors a lot of times during this conference, during DevOps. And 12 factors, by the way, is published by Heroku and set the 12 rules how to build your services not to get into problems. That's my definition. Maybe it's not perfect, but okay. So the scalability, there is a rule, share nothing. If you keep that rule, you can scale your service as much as you wish. And you can, in microservice architecture, you can scale your service which needs a load. You don't have to scale everything. You can choose that one which needs to be scaled. Replaceability, that's easy. The smaller, the easier to replace, of course. You have to remember about coupling, of course. Yeah, that's it. We probably have our problem solved. So we decided to go from the monolithic application to the microservices. The journey was really long. It took us 1.5 years or something like that. Even though we are not production ready yet, we are just before the open beta stage. So we have a lot of customers, but it's still not open to public, which we are planning to do in end of this year. But anyway, the journey was, I would say, bumpy. It's a topic for another talk. And we did a lot of mistakes. For instance, don't go with monolith to the cloud. You will create more problems than you will solve. Don't do that. But let's assume we are microservices, and we really are. So let's step back again and check the characteristics we liked in our previous system and how they look like in the microservice architecture. So first of all, we were not in the cloud. Now we are in the cloud. Hybris as a service, yes, is the shortcut. Yes, we reached the cloud finally, but what about easy monitoring? It doesn't exist anymore. Remember, every instance of the cluster node was the same. and the number of metrics were relatively low. Now, every system, every service can have different, different technology. We use Scala, we use Java, we use JavaScript, Ruby probably, and in addition to that, each of the service has different metrics, and aggregating them is painful, it's not possible. So, and there is more. We used Dynatrace as you know, as you had, as I said. Dynatrace is the monitoring system, is like New Relic or App Dynamics, and it cannot be used anymore. Why? The licensing model is not ready for the microservices. One license is really expensive. And if we had like 10 nodes of the cluster in the monolithic application, we had 10 licenses of Dynatrace, which is still expensive, but affordable. But imagine we have now 50 services, and each of the service in 10 instances, in average. And so 500 licenses is needed. And multiply that by price of the one license, it's a fortune. I doubt someone can afford that. So we need to implement our own monitoring for that. That's the problem of most of the companies. Debugging, next one. There is no debugging anymore. Yeah, the topology of microservice doesn't allow you to stop to connect debugger there. We need to implement even better monitoring to debug, to correlate request ID with the business transaction, to see everything in one place. Yeah, it's like print line debugging, something like that. So there are techniques, but the better monitoring is needed still. Next one, running whole system on one machine. That was really cool feature on our current system, our monolithic system. Currently, we don't have that. We need to use test environment more extensively. We had this environment anyway, but now we are using that for development. But currently, in the microservice architecture, you have to, again, take care of the one factor from 12 factors. So it is environment parity. So your test environment and production environment needs to be identical. Otherwise, expect unexpected problems, like it works on stage, but doesn't work on production, and work on my machine. What's going on? Probably some misconfiguration, difference in configuration in environments. That's really important, and that's not really easy to achieve. Sorry, I need to take some water. So the next one is easy optimization. It's the same as debugging. We need topology service to have holistic view of the system of the microservice, and this is not provided by any tool out of the box. Maybe Dynatrace can do it, but we cannot use it because it's too expensive. Okay, let's move on. In addition to technical problems, we screw up what we liked really much in our current solution, in our main product. There is challenges to the organization. How the architecture and organization are connected. They are connected by Conway's law. Conway's law says that you have to build your organization, your teams, in the way you would like to see your organization, your architecture look like. So the example is when you want the compiler, don't put 4 teams to build that compiler, because you will have 4-time pass compiler, which is not desirable at all. So, but let's step back. The inverse Conway's law says that if you have monolithic architecture, you have monolithic organization probably, and that was the case in our company. We had one core team, maybe some satellite teams, smaller one for all the modules, because our product is modular. But now we can scale our organization, but it causes problems. This causes challenges. Another thing about microservices and Conway's law, that each of the services in microservice architecture needs to be independent, needs to be self-aware, and you have to build your organization, your teams, to be independent and self-aware. So self-organizing, I would call it. So that's the connection between microservices and organization and agile. Conway's law says about that. You can conclude with that one service needs to have one owner. Of course, team can have more than one service, but one service needs to be owned by only one team. Otherwise, you get in the contention problems, in the communication problems. It's like in the Scrum team. If the more people you add to the sum, the number is 7, right? According to Scrum book. So if you exceed the 7 people in the Scrum team, your performance will degrade. The same is in the microservices. If you put too many people, too many teams in one service, you will slow down. There will be too much contention, and don't do this. This affects also libraries. When you are using libraries produced by other teams, the one team has to wait to. It's really clearly visible in the early stage of the project. So library is immature, has a bugs, has a lack of features. So the one team has to wait for the other team to fix the bugs, to implement features, and so on and so on. So don't use libraries. The approach I would recommend is to duplicate code. Of course, we don't want duplication, but duplicate code, and you find the common base for this code, create library, and probably open it. So publish it to open source community. Yes, of course. But it takes time. It's contention. It's the communication between two teams. Yeah, but the other in our case was that the other team had another priorities. They had to deliver some other features, and they said, "We don't have time for you." Yeah, that's the one way to do it, to fork and merge. So you can fork. We are using GitHub repository. You can fork the source code, and you can create pull requests. But again, I will tell you with the knee syndrome about that. So maybe now. Knee syndrome is not invented here. So we noticed something that there was probably improper communication, or the team wants to be really independent. If the teams want to be really independent, they don't like someone other to interfere. And if they refuse to use some untested code, really immature code. And solution for that would be exactly to create pull request for some feature. I don't know if I answered your question. Did I? Not really.
Sorry, because this problem is exactly the same problem when you have monolith, because still you can use the libraries and they have the same problems. If you wait for somebody else to fix
Yes.
that is fault, then you will block. So this is not really.
Yeah, but in the microservice, we should aim for the independence of the team, of the service. In monolith, you should also do this, but the monolithic architecture doesn't encourage you to do so. And usually with managers, they implement the feature the lowest effort possible. And you create dependency, you create contention. So we had this example with library. The one team refused to use other team library, and they implemented their own solution. And it turned out that the requirement for that library were stopping the other team. So the library was, designed up front, and then the functionality comes. And the functionality and the first idea just didn't match. So my recommendation would be to implement even duplicate code and then create library afterwards, not opposite way. Another problem with the organization and microservices is the example from Conway's law. When you want two services to communicate efficiently, you need to set up two teams to communicate efficiently as well. What problems might arise? We had the example with the time zones. We have a team in the Boulder, US, and in Poland. So the time difference is 8 hours. and the teams couldn't communicate really. So how it ended up, the team in Boulder just gather evidence that they spend more time for integration, for communication than to actually implement the feature they need themselves. That might be also an example for the managers' roles. So managers don't really get Conway's law, and this is their responsibility to communicate team, even they are not naturally able to communicate because of the time zone problems. Okay. Next one. Another problems, another traps of microservice architecture. You want to get microservice architecture, you are migrating from the monolith, but you can get monolith again. How to spot it? How to spot it? What are the factors? So first one is monolithic release cycle. It doesn't mean you have to release whole system. Even if you have 2 or 3 services which have to be released not independently but together, you have this problem. You're going the wrong way. So don't do that. I will tell you how we solve that. Another one is 2 big services. So we spotted that a lot of times. It's easier to add another functionality, another endpoint to the old service than to create new one. Too much coupling. Yeah, this is probably connected with monolithic release. So if you have too much coupling, you cannot release independently. And no replaceability, it means probably the same like 2 big services. So you cannot replace anymore the part of the system you would like to. So how to solve that? Monolithic release cycles. That's straightforward. You build it, run it. So DevOps culture. If you have separate team for the deployments, the development team will just transfer this problem to the DevOps team. So that's your problem, you solve that. If the development team is responsible for the releasing and they have 2 services which cannot be released independently, they will solve that problem at some time. Maybe not right away, but they will get to the point they want independent release cycle. 2 big services, that's quite easy. In big organization, and microservice work the best in big organization, we have a lot of non-functional requirements like documentation, security, logging, and stuff like that. And it turned out for us that to create microservice from scratch to the first service deployed was 2 days. And when we automate that, it was 20 minutes. And we have, after putting the name, pressing button, we have deployed service, we can access it, everything is configured, security, some black duck scanning, and every corporate requirements are there. So go this way. And another example about that is GitHub. Before GitHub, we had like 400,000 open source projects. After GitHub, so for now, we have more than 21 million. And in my opinion, is that creating open source project on GitHub is just putting the name and pressing button, create it. And that's it. You create open source project. Next one, too much coupling. How we solve that? We solve that to testing in separation from the test environment. So we just mocking the counterparts of our services, the services that our service is communicating to. If it turns out that you cannot easily write this mock server, you have too much coupling. Either it's too complex or too many calls. So do test in separation without the test environment. Of course, do as well the smoke testing or acceptance testing. That is not ruled out. Fits in your head. This is a solution for no replaceability. So keep the services small. That might be the answer of the size of the microservice. So of each organization, the size it's different, in my opinion. But you should say yourself, do I dare to replace that? can I replace this? If I'm too lazy, it's maybe okay, but if you need another team to replace some microservice, it's too big. You have to cut it down. Of course, it doesn't have to be must not be too small, because we will end up in communication in the network traffic issues. Okay, next problem, ball of mud. We got to the stage, we have no control anymore of our microservice system. So first symptom is unorganized services. How to solve that? We can solve that by inverse Conway's maneuver. So if you spot you have unorganized services, you probably have unorganized teams in your organization. So fix the teams, and naturally the architecture, the organized services will untangle somehow. Another one is God services. So services which knows too much or does too much, do too much. So solution for that is vertical teams. Usually, God services are the persistence. Maybe not usually, but in our case was the persistence layer. So forget about three-layer architecture. So the one team is building persistence, second team business logic, and third one is doing the user interface. Split the functionality vertically. So small pieces, but from bottom to the top. So it means that's only recommendation, of course. It's not always possible, but each of the service should have its own persistence. That would be the ideal one. And then you avoid God services and you avoid tangling. Next one is versioning. So don't do versioning. That's usual mistake. Instead, you may end up in your business transaction that your service will be called 3 times, and each call will be in different version. Untangle that is, I think, almost impossible. So how to solve that? Use tolerant reader. Tolerant reader is really nice reactive pattern and is sometimes really easy to apply. So if you call some other service and you expect that it accepts your response, and you only need that it returns OK. Don't tie it up to single response code, to 200 or whatever. Just there is a response family. So you can check response family, so from 200 to 299. If service responds with that, you are OK, job done. Another example is validation. If you need 1 or 2 attributes from the payload, don't validate the payload. This service can update payload, remove attributes, add new one, and your validation will fail even if you need only those 2 attributes which are still there. So that's the examples of tolerant reader. Another one is unorganized communication. It's quite simple to organize services, but for that you need a topology service. You need holistic view how the communication looks like in your microservice system. And having topology service, you can do choreography. You can optimize communication, business transactions, so on, so on. So do choreography. And the last one, but not least, don't use transactions. Transaction is the modularity killer. It just couple several services together, and you cannot do anything without that, probably. Use eventual consistency, CAP theorem, transaction compensation. There are a lot of tools not to use transactions. Okay, I was talking a lot about monitoring, and it deserves its own slide. So how we see now what is the responsibility of the monitoring. So first one is centralized logging. That's the responsibility of monitoring. You need to have all logs in one place. If you have 50 services, there are 50 potential places when you are looking for the root cause of our problem. So do centralized logging. Another one is debugging. So correlate requests between your services and log them. That's also responsibility for debugging. Now, another one is alerting. Alerting is connected with DevOps culture. So if the team is responsible for the deploying to production, it needs to be alerted. It needs to know that something is going wrong and needs to have time to react. Maybe not time to react, but be notified as soon as possible. This is interesting. Testing. I read that testing is, monitoring is modern way of testing, and I kind of agree with that. Example is canary testing. So this is done by monitoring. You put two versions of your services to the production, and you just route part of the traffic to one service and check the error ratio and other characteristics, and you then you can make decision to roll out this change or not. So testing is also covered by monitoring. And the last but not least, anomalies analysis. Remember, in the monolithic, we have quite a few metrics. Now we have hundreds or even thousands. So there is no one single person who can have holistic view of the system. We need the system to track the trends in our system. We need a service to track the trends in our system, to track, for instance, memory leaking, so memory usage trends, something like that, and alert us something might go wrong. So we need that. We don't have that, but this is problem of a lot of companies dealing with microservices, and we are not alone. We see the urgency of anomalies analysis right now. Okay, that would be it. Let's summarize quickly. From my opinion, the technical goal for the microservices maturity is continuous delivery. To have continuous delivery, you need advanced monitoring, independent teams, and all stuff like that. So, but what we are doing to achieve continuous delivery? Sorry. What tools we are using? Or techniques. So first of all, DevOps culture. Without DevOps culture, there is no continuous delivery. The example, if you want to work with microservices and you apply for the job, just ask them who will be in charge of delivering, of deploying software to production. If they say, we have manager doing that, just come to us. We are hiring, by the way. Next one is reactive manifesto. Reactive manifesto is a set of 4 rules to have application really reactive, responsive, event-driven, and so on. So follow that rules. We are trying to follow that. 12 factors, I was talking about that. Really nice, really useful rules for the designing your services. And use reactive patterns like tolerant reader or histories. Circuit breaker, for instance. We are using a lot of histories, but not only for reactive patterns, but also for advanced monitoring. So out of the box, we have monitoring, we have histories dashboard, we can see a lot of things going on in our service just only by using histories library. For centralized logging, we are using Logstash. It's really nice. For alerting, VictorOps. For gathering statistics and so on, Graphite and Riemann, probably. For the independent teams, just use Agile. Remember, I told you, and I think that's true, there is no microservices without Agile. Remember about Conway's law, and remember about vertical teams. Otherwise, you will get mess in your system. And above of all, keep it small. The micro in microservices was not by mistake. It has to be really small. But nevertheless, the continuous delivery, all the technical goals, they are not business value for the customer. So what is business value for customer and how microservice architecture helps with that? So for us, for me, the low cost of experiment is the something worth tackling all the problems I was talking about. So you can have really fast feedback loop. You can try and error on the live system without, the system has to be resilient. So there is no big risk to put new feature to the system and just get feedback. If it fails, someone says, either you win, either you fail. Either you win, either you learn. So that's the way. And you are not coupled to one technology. You can choose technology directly for the problem you are solving and just inject this service with different technology to your architecture, your system. And that would be the reason you should go. I recommend to go with microservices. Thank you. Any questions? Yeah.
Quick question. You said that you described your system, the old and new version. Do you have a single instance with accounts for your customers, or do you install it in-house in the customer's side?
But in which system? In all?
The microservices, for example, approach. Do you install them on-site for your customer, or do you have a single environment?
We have our own cloud, and we are selling product. We aim to sell product as a service, so we deliver services. Yeah, not hosting. In the previous version, that was on-premise only. I would say, we had partners which developed and deploy this solution on-site for the customer, and usually customer like that, wanted that. They own the servers and they own the data, everything.
Okay.
Any more questions? Yeah, go on. Once again?
In the context of choreography, you mentioned a topology manager.
Topology service. No, we are developing that based off Neo4j graph database. We just trying to build this topology with nice visualization and flows, everything. I don't know the tool which can fit us with this topology overview. So we're building it ourselves. Yeah.
In this microservices architecture, there must be some penalty for the communication between services. Do you measure this penalty in comparison to monolith when there is no penalty?
Do we measure? It's really hard to compare because currently there are completely different systems, but nowadays we're trying to parallelize the calls. So we have something like mashup service, and it calls different services simultaneously. So the time of the call is the slowest response from all the services we are calling. But you need better monitoring to measure that, and we are aware maybe we'll migrate to some other protocol. There are plans, because currently we are using HTTP over REST over HTTP. Maybe we are migrate to some other protocols when we get this kind of problems. But currently we haven't measured it. Yes, please?
So you said you're not versioning the microservices you're using. So
We're trying not to, yeah.
So how do you make sure that releasing new microservice won't screw up the communication? So are you using consumer-driven tests or stuff like that? How do you test the interaction? For example, you're not break, right?
So actually we version our services, but we don't put two versions to the ecosystem at once. So there is always one version, the latest one. And how we test it, we have acceptance tests. We are using Spock testing. We write our acceptance test. We have also end-to-end scenario testing. So there are separate service which test cyclically end-to-end flow within the system.
Yeah, but you have a microservice that is used by 20 different consumers. So how do you know if you didn't screw up 3 of those when releasing new version?
We don't know for now. We do it from canary testing, right? We install new version. as a mirror of the first version for some time, and we check if it's working or not. Then we have some certainty we can roll out or not. But there are plans to introduce packed testing. So this is packed from the Martin Fowler. We just, you know, right now not. But plans are to have a lot of things. I don't know how much time we'll have to implement all of those. Yes?
If you had a second chance to make to start developing this from the scratch, you would go with the microservices or something else?
Actually, I had a second chance because I started in different projects on this same system, but different project. I was starting with persistence. And after several months, we had like 3 or 4 microservices. They were not micro anymore. And now I'm working in the project of this customer profile I was talking about at the beginning. And we, after 8 sprints, we have 12 microservices. And I would go in that way. The cognitive law, the cost of experiment is really great. I would go that way, yes, again. Any more questions? Yes?
One thing that I find myself personally just hard to imagine is the lack of transactions. I mean, I assume it's only the case of a given business that you can apply it to, but what do you do about it? I assume that there are some business cases that just have to happen or not, and eventual consistency is just not good enough, like in a banking application.
Honestly, the banking application is the perfect candidate for not to use transaction, to use compensation, transaction compensation, I think. There are proofs that you don't have to use transaction for that. I heard a lot of people saying they need to use transaction for certain problems, but if I get these problems, I always find a way, I always see the way how to do it without transaction. You can have compensation, you can have a lot of eventual consistency. There is a really lot of tools and articles about that. And yeah, I think we can go without transactions. Transactions are not natural for the real life, for the environment, for the nature. There are no transactions in the nature, in the processes, in physical processes. That's what I think.
One more question. Let's say that you talk to your manager to use this architecture and in the microservices. What are then, let's say, the business drivers that you want to use microservices? Let's say your manager asks you, why do you want to choose this architecture? What is the main business driver to use microservices versus, I don't know, the monolithic architecture, for example?
So again, the last slide, the low cognitive load, the low cost of experiment. During my career, I haven't found such an architecture that the experiment was so easy like in microservices. And the more you experiment, the potentially your product will be better. You get faster feedback from customers. That's what I say. But anyway, if you have manager, it would be really difficult to migrate because manager don't really know. They have to change their mindset to go in the microservice architecture because they need to step back to give our decision power to the teams. That's the way that it should work. So we are using PaaS. We are using Cloud Foundry for deploying that. We have separate team taking care of environment of our cloud and Cloud Foundry. I don't know if it's good or bad, but yeah, we are working like that. Maybe it will be changed. So the microservice should be really simple and the interface should be clear. And we aim to do that, to achieve that. And anyway, the complexity of the solution will be the same in monolithic application and the microservices. This is not the case. This is not difference, I would say. So the number of interfaces, the number of connections will be the same. You need, of course, the topology service to see how the business transaction flows. But apart from that, I think there is no difference from the other architectures. Any more questions? Yeah. Backward compatibility? No. Tolerant reader. To some extent, yes. I would say there are different approaches. Of course, you don't design your interface perfectly from the first time. So we were thinking about something like grace period or something like that. So we support only for 3 months certain functionality, but we try to avoid that as much as possible and convince our customer to use tolerant reader. And also inside the ecosystem, inside the teams, we are doing some exercises to break some functionality and some interface and see how the other behave and if they implemented tolerant reader properly or not. So that's the approach. But if the interface changes completely, you have another, it's not even a different version, it's another microservice, in my opinion. So you just deploy new microservice with completely different interface, even if it quite do the same-ish like a previous one. But it's not even different version, it's different microservice.
Do you also use some sort of chaos monkey test?
Yes, we are trying to do some, it's called, how is it called? Wednesday? Cracking Wednesday? How is it called? No? Something like 1 day per month, we try to crack everything, put latency monkey, chaos monkey, something like that. But it depends on the team. Team has to decide. We are really on the early stage. We are not in the production yet, so we need more functionality than the stability currently.
Okay, I meant something like randomly shutting down any given microservice all the time. I mean, for example,
No, we don't. But I had this presentation from Greg Young, and it inspired me. And I think we introduced that. Yes, please?
I would like to imagine your system, this microservices architecture. So you had one monolith, and how many microservices do you have now? And how many teams?
How many teams do you have? 10? Something like 10 teams. It's really distributed. We have teams in Montreal, in Boulder, in Munich, in Germany, in Poland. So it's quite 10. It might be different when I come back to my job, to my desk. And microservices, I think between 30 and 50 currently, if not more.
So how big was your project at the beginning?
Once again?
How big was your project at the beginning?
At the beginning? How big? It was 0 at the beginning. No, one sec, sorry.
In the line of codes, for example.
How many line of codes? I haven't calculated that.
And the second question, if I may.
Yes?
Do you use this technique when one microservice is one VM?
Yes, we are using Cloud Fun, one VM, yeah, one container. So we deploy application with the one server, Jet or Tomcat, with one application on that, yeah. If that answers you. Okay. Any more questions? Okay, so thank you very much. And have a great end of conference. Thank you.